So this is section 2.6, and in 2.6 we're interested in derivatives of the inverse functions. Derivative of f inverse. And actually we can think of it as what is the relationship between the derivative of f and the derivative of f inverse. Okay, so in this case, in this section, we define the inverse of f to be equal to g, and so let f of x be a function, and let g of x be the inverse. Okay, so g of x is actually, in notation, you could write it as f with a minus 1 on top. Okay, good. So now we want to try to figure out what the relationship is between the derivative of f and the derivative of g. Okay, and so just in general, if the point AB is on the graph of f, right? So let's draw a point here. Let's say that this is my point AB, and I know this is on my graph of f, so I might have something, let's say that it's something like that. Okay, then what point is on the graph of f inverse? Remember, you switch the role of x and y to get on the inverse, and so if AB is on the graph of f, then BA is on the graph of f inverse, which we're calling g. Okay, and so we'll go ahead and maybe draw the line y equals x, and then we'll flip that point over to here, right? And so now this is A, B here. Okay, so what would the graph of f inverse look like? It'll be something like that, right? Good. All right. Now, let's go ahead and take the derivative now. So we know that because f and g are inverses of each other, we have that f of g of x is equal to x, right? For all the x in whatever restriction we are. Remember that sine and cosine, for example, had to be restricted for the function to be invertible. Okay, and so if we differentiate both sides using the chain rule on this side, right, derivative of the outside times the inside plus derivative of the outside, did I just say that? Derivative of the outside with the inside function stuck in there, times, that's where the product is, g prime of x equals 1. Good. So now we can plug in the point B in this case. So that means that f prime of g of b is times g prime of b equals 1. Because remember, BA is on the graph of g. So what is g of b? G of b is equal to a, right? By this. So therefore, f prime at a times g prime at b must be equal to 1. And so from here, we get that g prime at the point b is equal to 1 divided by f prime at the point a. Okay, so this is the slope of the tangent line at the point BA for the inverse. And so the slope is the reciprocal, 1 over f prime. So here our slope might look, well, in this case it's kind of looking a little too similar to, it's almost equal to 1, right? And so the reciprocal of 1 is just 1. So let me draw that so that this slope is closer to 0, maybe, and so this slope would be closer to 1 there. Okay, or bigger than 1. Good. And so if this slope is slope m, this slope would be 1 over m. Okay, and so the points are switched as well. Good. So given that f prime of a is not equal to 0, what would the tangent line be for g of x? Well, we would still have our y minus b equals a slope times x minus a. Oops, that's for the other function. Let me flip those. Y minus a is equal to some slope times x minus b. I keep saying that. Good. So this is for the inverse, right? And so we know that g prime at b is going to be 1 over f prime of a. Good. So remember that the original tangent line for f would be y minus b equals f prime of a times x minus b. So do you see how we would get the tangent line for the inverse? You swap, once I get used to drawing that for a, swap a and b, and then take the reciprocal of your slope. Good. All right. I hope that was clear. Let's maybe do an example. I'll pause to put an example on. All right, so continuing on here, I've just written up a quick example. Suppose that the point 1, 3 is on the graph of f, and we assume that f is invertible, and in particular, f prime of 1 is something like 4/3. Then what can you say about the inverse of f if we call it g of x? Right, first, the point 3, 1 is on the graph of f. Oops, sorry, g. So notice what that means. That means that g of 3 is equal to 1, right? And then originally, this means that f of 1 is equal to 3, right? So that's their inverses of each other. Good. 2. If f prime of 1 is 4/3, then, using our previous discussion, g prime of something is the reciprocal of that, which would be 3/4. Now what would go in here? Well, it's not the 1, right? The 1 was for the f, and so the corresponding domain value for the inverse would be 3. So g prime of 3 is 3/4. Okay, so now we have a point and a slope, and so the equation of the tangent line to g of x at x equals 3, oops, yes, x equals 3, is y minus 1 equals 3/4 times x minus 3. So just as a point of comparison, what's the original tangent line, or the tangent line to the original function at the point 1, 3? It would be y minus 3 is equal to 4/3 times x minus 1. Good. And so that's the relationship, right, between the original function and its inverse. Good. All right. I'm going to stop here, and then in the next video we're going to use this idea of functions and their inverses to find derivative formulas for y equals the natural log of x, and then y equals the arcsine of x, and then y equals the arctangent of x. Okay, so the same technique will be used for all three. All right.